Okay. What we're going to do in this video is we're given this position vector r, and we're given both of its components. We're going to find the length of the curve from 0 to pi over 6. Now, so what we do when we originally, in order to find the length, what we have to first do is to take the derivative. So we have to find the derivative of this vector. Now, when we take the derivative of a vector in its component form, what we're actually just doing is we're just taking the derivative of each component. So what we do, what that ends up being, is negative 9 cosine squared of t sine of t, and then 9 sine squared of t cosine of t. And all I did right here was I took chain rule. 3 times 3 is 9, and then reduced it by 1, so now I have cosine squared of t, and then that's multiplied by the derivative of cosine of t, which is negative sine of t. And then similarly you do the same thing with this. Now, I'm going to change colors, but what you need to find now is, the length. And in order to find the length, that's the same thing as taking the integral from pi over 6, or from 0 to pi over 6 of the whole velocity, not just each individual component, but the actual velocity at any time t. So in order to find that, we take the square root, and I'm just going to write it like, hopefully this can fit. We're going to take the square root of 9 cosine squared of t sine of t squared. Man, this might not fit. Let's try to get it. 9 sine squared of t cosine of t. Well, it'll fit. Okay, so in order to find the actual velocity at any time t is technically the square root of this. Now, if you were to integrate the actual velocity, you're going to get the actual length, or you're going to get the total length. And when you integrate it with restrictions, you're going to find the length between the particular time t, or the particular values of t. They never specify if this is time or not, but I'm assuming it is. Okay, so what we're going to do now, I don't like that color, so what we can do now, I'll write it over here, is we're gonna expand and simplify this a little bit. So when you square this, you get 81 cosine to the 4th t times sine squared of t. I don't know why I just did that, but it's okay. And then 81 sine to the 4th t cosine squared of t, and then that's to the 1/2. And now what we can do is we can start factoring out things. We can factor out an 81. We can factor out an 81. We can factor out a cosine squared, because there's a cosine squared in both of these terms. And we can also factor out a sine squared, because there's a sine squared in both these terms. So when you factor out an 81, what you're left with on this side is you're left with just a cosine squared of t. Because if you were to multiply this all back in, you get 81 cosine to the 4th sine squared of t, or cosine to the 4th of t and then sine squared of t, which is just this. And then when you do this on this side, you'll just be left with sine squared of t. And all I did was factor it out. And then amazingly enough, this just ends up being 1. So now you're left with cosine squared of t sine squared of t. The integral of that from pi over 6 to 0 with respect to t. So Okay, this can simplify even more to 9 cosine. I'm going to write it on the other side, and you'll see why. 9 sine of t cosine of t. All I did was take the square root of this, because this is to the square root, so with respect to t. And what this is now, this is the u substitution. So let u equal to sine of t, and when we let u equal to sine of t, that means that the derivative of u is cosine of t dt. And this is why I put it here, but we have the du term right here, and then we have the u term right here. So what we can do now is that we can substitute in. So you get 9u du. What we can do now is we can change the restrictions. What you can do, you don't have to do this, but I will. You can change these restrictions, because you're not. These are restrictions with respect to t, but now we're putting things with respect to u. So in order to find the new restrictions, what we do is we take this right here, and we just plug in the old restrictions, and then you'll get the new ones. So I'll do that. I'll do that with I'll do it with this color. So when we plug in 0, we get u is equal to the sine of 0, and that is just 0. So this term doesn't actually change. I'm going to erase this for a second. So when we plug in 0, this doesn't actually change at all. So that's the new restriction of u, which is just the same as the old one. And then when we plug in pi over 6, which is what our old restriction for t was, we end up getting 1/2. So now we know that the new restrictions are from 0 to 1/2 with respect to u. Okay, so now we can integrate this. When we integrate this, we get 9/2 u squared from 1/2 to 0. And that's simple enough. What we can get, we get 9/2 times 1/2 squared minus 9/2 0 squared. And that ends up just being 9/2 times 1⁴, or 9/8. So, thank you. I'll see you in the next video.